Hello everyone and welcome back to another video. Today we are looking at a company called Quintessence Labs, another one of those companies that are active in the space of quantum cybersecurity. And if you are interested in that, then of course stay tuned for today's video. But also if you have no clue what I'm talking about and if you want to know why this might be a problem to think about, then also today's video is the right one for you. And with that, let's start right into it. So quantum cybersecurity, how is that even important? Why do I keep talking about this in the upcoming videos? Well, the idea is that in the future with quantum computers, you will be able to crack today's security, today's encryption. We have a world where we are using, or we are in a world where we are using prime numbers, and especially the distribution of prime numbers, or the not understood distribution of prime numbers to actually encrypt our messages. So the idea, the underlying concept is that when you multiply two different prime numbers with each other, it's a very simple thing to do, multiplication. But if I give you the product of these two, so the result of the multiplication, it is not so easy for you to figure out which two numbers I've been multiplying with each other to get this number. Now, with that said, that is what today's encryption relies on, and it's actually something that is hard not only for you to solve, but also for your computer to solve. This completely changes when we're looking at the world of quantum computers, because there we have something called the quantum Fourier transformation, which enables us to actually probe a lot of these prime numbers at the same time. And this is something that Peter Shor has discovered, and that's why it's called the Shor algorithm, that can be used to crack basically the underlying paradigm of today's encryption. Now, we are not yet at the point where any one of those quantum computers that you can find on the market can actually break a meaningfully encrypted message. So basically, we are not yet at a point where this is critical. However, this might very soon change because of two facts. One, the quantum computers are getting better and better, right? There's more qubits that can be used. We have the first cases where they can run error correction on top, so that you can also run very deep and complicated algorithms. And on the other side, we have the algorithmic improvement. So companies that are working on new algorithms that can run more efficient on today's existing hardware. Because when Peter Shor actually worked on his algorithm, there was no quantum computer. So he basically just, let's say, took it from a very conceptual level. But of course, now that we know what, for example, the hardware of a company like Electron looks like, that is working on, in this case, ion-based quantum computers, then of course we can go back from there and actually derive an algorithm that runs more efficient on such a machine. Still, we are not yet at the point where any one of those computers is able to crack some meaningful encrypted message. However, the important thing is that the trajectory is there, right? We are moving closer to this point. And that's also why places like the American National Institute for Standardization, NIST, actually started to create roadmaps also for the public public institutions to think about this, because there is something called also harvest now, decrypt later. So you could, for example, today eavesdrop on somebody's encrypted message, right? You could just, let's say, sit in between and listen to what they're communicating in an encrypted way that you today cannot break, but you can store that somewhere for later. And then once you have the quantum computer, you can crack this encryption, right? So this is already a risk that is out there today. For most of our day-to-day, let's say, communication, this is probably not super important, right? If you think about, let's say, you're logging into your bank account and then it does the two-factor authentication where on your phone you have to type the number that you see on the screen. Okay, there it's not super important because this is anyways only usually valid for a couple of minutes, and after that it expires, and even if you know the key by then, you cannot log into somebody's account anymore. However, it might be a very different story when we think about your health-related data. Let's say you have some disease, you go somewhere, get a measurement, like your blood measurement or something done, and now your doctor is sending you this information. Well, I mean, this is encrypted. So as of today, nobody can eavesdrop in between and retain this information. However, if somebody could eavesdrop in between and collect that information, they might in, I don't know, 10 years, 20 years, 30 years, maybe 50 years from now, who knows what's in 50 years from now, could kind of hop in between and use or let's say take the quantum computer and then finally decrypt this information. And you might still be alive in 50 years, right? So you want to care about the fact that these secrets, they remain secret for the rest of your lifetime. And okay, maybe it depends a little bit on what medical data we are talking about and who could be interested in that, right? But generally, I mean, it's your personal thing and you don't want it to be available to others. So there it already starts today to play a role, because even if there's just a, let's say, 10% risk that we make it within the next 50 years to a point where on the algorithmic side and on the quantum computer side, we are at a point where we could break today's encryption, even if it's only 10%, I think it's also already there. So we need to think about this very early on. We need to think about how can these messages be encrypted in a better way that might not be able to be cracked by a quantum computer? And how can we also, on the other hand, make sure that we exchange these secrets in a way that maybe nobody could eavesdrop in between? And that's where quantum key distribution comes in. That's where quantum encryption algorithms come in. And that's also where Quintessence Labs is sitting. And with that, let's now actually hop into their website and see what they have to tell us. So here we are, Quintessence Labs. It says over here, future-proof encryption for the quantum era. Achieve quantum resilience with post-quantum cryptography and crypto agility at your fingertips. We built the tools to counter quantum threats. So strengthening data encryption, high-speed quantum random number generator, then crypto agile key management, so flexible deployment of crypto algorithms, and then quantum key distribution, use laws of physics to secure key distribution. There's a couple of different things, right? So random number generators, quick step back on that. You do have a way to create random numbers today in your computer. You can just press a button and it will give you a random number, but actually the number is not super random. It relies on an algorithm that is sitting below that is using measurement, for example, time values or something else, your calendar date and time, and calculating a number for you that looks random, that is probably also distributed quite randomly. But then if you're really looking at the details, it might still have a certain bias for specific numbers. So it's probably not exactly the same probability for every single number. And what is even worse, if you have, let's say, the input values of the algorithm, if you know them, and you can trace them back, you can actually figure out what is the number that somebody randomly generated. So it's not that random, right? That's where quantum physics is very interesting, because as of today, quantum physics is our most precise theory of the world by every measurement. And the underlying concept of it is that there is only probabilities. So if something is set to a superposition between bit 1 and bit 0 that is exactly at 50%, then it's really truly random when you measure it. If you get a 1 or a 0, and it will be fully, let's say, equally distributed, so it's really 50-50% if you can perfectly set up the system like this. And it's really fully random. And there are different ways of doing that. You can use single photons. There are you can use radioactivity for that, like various different approaches to actually create those using quantum systems underlying. Then we see here this crypto agile key management. So what are these keys, right? Now you're using these random numbers. You're generating strings of random numbers, ones and zeros. And you can use them as keys to encrypt the message. And that's basically this part here to manage those keys. And then you have the key distribution as well. So that's about how you can actually share those randomly generated keys. And there's this whole paradigm, this whole idea of quantum key distribution using the non-cloning theorem that makes sure that you cannot eavesdrop in between, and many other things in this context. Let's see where the company is actually offering services in these domains. Now, what else do we have here? So CISOs should familiarize themselves with current quantum tech. So I guess this is cybersecurity, chief cybersecurity officers or something like that. Chief information cybersecurity officers, not sure. Start including quantum safe solutions in their lifecycle management, focus on improving crypto agility, and prepare for the implications of infinitely more powerful computers today. Okay, and then we see here some information about, there's this little carousel here with, I guess, some relevant information. So capable quantum computers will break public key encryption. And there we see what I just talked about, right? There's the Shor algorithm, which can break the asymmetric encryption algorithms as of today. There's the Simon one that can basically break the authentication mechanisms, the MAC and the AEAD modes. The only thing that is still not fully broken is the symmetric encryption, but there's the Grover algorithm, which is also called needle in the haystack, I think, where you can already weaken this whole idea of symmetric encryption. So again, there's a chance that this could also break at some point, or at least it's weakened. And then, I mean, okay, no communication link will be trusted to be secure, communication would not be trusted to be authentic, and then transaction could be repudiated. So now there's this other party of the banner, right? So much closer than they appear. Quantum computers that can break public key encryption are closer than you think. And there's a couple of information listed in this table here. So old way of thinking, 1,000 of stable qubits are required, 1,000 of stable qubits. Classic programming and 5 to 25 years led to a low risk, but the new reality is that state secret and new algorithms make it much easier. You might only need 100 of stable qubits. AI and machine learning help you to build better algorithms faster. And okay, their conclusion here is that it might only take 1 to 3 years. Also written here in the text, right? Every crypto system gets broken eventually. There's a clear and present risk to public key encryption. RSA will be broken in 1 to 3 years. If not by quantum computers, then by traditional silicon. It is coming. Public key encryption is at risk. We can't ignore 30 years of progress and assume Shor's algorithm is the only way to break encryption. So there's also the AI path, right, to discover new algorithms faster using computers, using machine learning. And that is parallel to the quantum computers putting, let's say, the asymmetric encryption at risk. And that's kind of the underlying idea. Now, unfortunately, there's no, let's say, backing for these numbers. There's no explanation how they are coming to it. There have been other companies that I reviewed before. And if you haven't seen all of the videos, go check out the Hidden Quantum Champions playlist, because there you can find all of the videos that I made, and there are other companies in the realm of quantum cybersecurity that have also some records on that, as in like papers and public places announcing certain things. For example, mapping what I talked about before, right? The NIST roadmap towards new encryption paradigms, things like this. You should go and check those things out to also make up your own opinion about the time frame here. 1 to 3 years is, of course, already very close. Other people might be a bit more conservative here. Depending on how you interpret the data, it can be reasonable, but it can also be further ahead in the future. But that's, of course, up for everyone to make their own assessment, and you should make your own assessment when you're talking about the sensitivity of this personal data. So, if RSA was broken tomorrow, what would you do? In December 2022, there was a wake-up call that RSA 2048 would be broken with 300 qubits, not the 1 million qubits predicted originally, right? This Chinese research paper, which has since been debunked, to the method in which they could use a much smaller and currently available amount of quantum computing power to break RSA. So Okay, and then you see here this workflow, right? What experts think. So there is some expert panel down here with some related information. So you see here the French National Cybersecurity Agency, the Chinese one, Chinese threats in a quantum era paper. Then there's something here from the White House. There's something from Homeland Security and NIST, so which I talked about before, MIT Technology Review, and Quantropy, which is a company in the field of this quantum cybersecurity. And they are all putting specific statements. I'm not going to go through every single one of them now, but maybe just as two sources, maybe on the one side, something that is, let's say, more on the politics side, from the White House, right? America must start a lengthy process of updating our IT infrastructure today to protect against the quantum computing threat tomorrow. And then from MIT, the threat is that they copy down your encrypted data and hold on to it until they have a quantum computer. And that's this idea of harvest now, decrypt later that I was talking about before. Okay. Then, here you have a couple of customers and projects and partners that they work with. I think a lot of known labels. So you see here EY and Deloitte, for example, and Quantropy as in the partners, but then also customers. You see, for example, here ZF, which is a tier 1, I think, automotive supplier from Germany. You see, for example, here Boeing as one of the big players in government and defense space. And then in the banking, you see, for example, RBC or Wells Fargo as players that are already working with Quintessence Labs. Then, as per usual, down here we see the company-related information, right? There is a lot of information about the products, why them, resources, company, and we are going to look into all of that later down in this video. Of course, we cannot look through all of this. You see there's a lot of different products. And a lot of information available, and I encourage you, if you are interested in this, to also check it out yourself. There's the Quantum 101, I guess that's where to start. But we are now going to quickly look over the products. So you see here Quantum Enhanced Cybersecurity, Trusted Security Foundation, Key and Policy Management Platform, KMS, QStream, so Quantum True Random Number Generator, QStream Entropy as a Service Solution, QRAND Entropy Management Software, QOptica 100 Key Quantum Key Distribution, QConnect Quantum Safe Key Distribution, QClient Software Development Kit, and the QProtect OTP Encryption. So you see it's the whole stack, right? It starts from, let's say, the number generation and the key distribution basics all the way up to the management platforms to actually handle those data streams and handle those encryption streams. So it's basically a one-stop shop for quantum cybersecurity, quantum enhanced cybersecurity. Just to see one of the examples, let's quickly look at the quantum key distribution here. So you see there is some hardware, it's rack sized, right? It goes into your existing compute infrastructure, and it says our continuous variable quantum key distribution CVQKD technology is the most secure means of distributing keys protected by the laws of physics. Point-to-point control that uses specialized hardware to share secret keys over an optical link. Secrecy of the keys is guaranteed by the laws of quantum physics, offers CVQKD technology with built-in advantages in terms of cost, form factor, and performance. You see there's a lot of other things, right? There's a lot of other hardware that can be fit into your rack. There's a PCIe form factor for the quantum random number generator. And you see there's also software available on top of that. There's solution partners that can also help, I guess, Quantropy that we've seen before, but also others. And then, you can get, let's say, the full offering from them. Why Q Labs? Why Quintessence Labs? So we are the global leader in quantum security, it says. at the forefront of quantum cybersecurity. Our capabilities extend from quantum-enabled key generation, crypto-agile key and policy management through to quantum key distribution, helping to build a quantum resilient future for your organization. What sets us apart, and that's maybe the interesting part, right? So Quintessence Labs portfolio of modular security products addresses the most difficult security challenges facing organizations, helping implement robust security strategies to protect data today and in the future. Our technology, our company, and our people can be accessed later on. Maybe about the technology, so seamless integration. The Quintessence Labs world-class products incorporate advances in quantum science to deliver high-capable cybersecurity solutions, then harnessing quantum science. So our products seamlessly integrate with existing devices in your security infrastructure to easily and cost-effectively strengthen your data protection, and then solid security foundation. So our TSF400 is a highly secure crypto-agile platform combining our powerful key and policy manager, our high-speed quantum random number generator, and a FIPS validated hardware security module in a single centralized solution. There's a couple of awards that they've been winning, like the Australian Museum Cyber Tech 100 Award, and so on and so forth. The company values, so trust, recognized by the World Economic Forum for our work in quantum cybersecurity innovation, stronger together, partner trust layers in cybersecurity, and then aware we are developing new advanced technologies to continue to reduce your risk. And there's more information down here. We work with the best, so a couple of partners listed here, like JP Morgan Chase, Verizon in the US as a telecom provider, I think, and then Microsoft as a software partner as well. And there's further resources listed down here as well. Now let's quickly check out the news section of this company, just to make sure we are pretty much up to date still, or maybe it's not. So recent articles are from December 2025. I'm recording this in May of 2026. So let's say there is a little bit of a gap now in terms of the activity. There's more articles linked down here. And then as per usual, let's also quickly check out about the company itself as we are moving towards the end of today's video. So the future is bright. We are too. Australian-based Quintessence Labs is a global leader in quantum security, cybersecurity, recognized for its advanced quantum resilient data protection capabilities. Why Quintessence Labs? Quintessence Labs is at the forefront of quantum cybersecurity, providing the strongest data protection to keep your information safe against today's and tomorrow's threats. Our capabilities extend from quantum key generation and crypto-agile key management through to quantum key distribution, helping you to build a quantum safe future for your organization. Then here you see the management team, the leadership team with the founder and CEO, which is Vikram Sharma. And then, of course, you also see there's a chief financial officer, chief technology officer, US operations president. So the company is scaling. There's, let's say, proper company functionalities. It's not just not anymore at the stage where you have two co-founders sitting in a garage and developing something from scratch. Okay, and I mean, then there's further information here about the awards and so on. But I think that's, let's say, the superficial information that we need. So Quintessence Labs, an Australian-based company in the field of quantum cybersecurity that has a broad network of partners they are working with to deliver the full stack solutions, including, of course, hardware that they manufacture or that they sell by themselves, which generates, for example, quantum random numbers, all the way to the quantum key distribution, and then further down the road, also the implementation within different organizations. You see they have customers already from different domains, from different industry verticals. And they are already working on implementing quantum cybersecurity in today's organizations. They also have some information about why this is becoming more and more relevant. They have some idea about the timelines that are mentioned here on the website. Of course, there are different opinions out there on the market depending on whom you ask. But definitely, if you are, let's say, based in Australia, I think it's anyways worth checking them out. But you see, they also have a global partnership or global customer footprint, so probably also for other regions. If quantum cybersecurity is something that is not on your radar yet, might be worth reaching out to them, might be worth checking back. But of course, there are also other players in that market. And I mean, you find them in the Hidden Quantum Champions playlist. If you don't want to miss out on the next company about the cybersecurity, quantum cybersecurity stack, or maybe the quantum sensing or computing, then make sure to subscribe to this channel. You should anyways, because you watched it all the way to over here. Make sure to stay hydrated, and I'm going to see you back in the next one. Until then, bye-bye.